Hi, ECON 345. I hope everybody is doing well on this fantastic day. The weather has been great and beautiful. It's kind of getting a little chilly outside. You can tell that fall is right around the corner. Well, with that, I'm going to go ahead and get started with this material for the week. So we do actually have two interesting subjects that don't directly relate, but we're going to talk about them in the same week because there are two shorter sections and I wanted to be able to put them into one week where you can cohesively talk about them. So let me just go ahead and start sharing screen here. Okay, so the first topic that we're going to talk about for the first half of this lecture, or for a majority of this lecture, are going to be environmental regulations. So some of the major changes that have happened over the past 30 to 40 years and what we've learned about externalities from these different sort of regulatory policies and what we can learn as public economists. The second one's going to be public defense. So security economics is a really new field in public economics. It's just really starting to grow and people are starting to understand it and specialize in it. So I'm going to give you kind of an overview of what that looks like so it's something that you're familiar with. Okie dokie, well, let's go ahead and jump straight into environmental first. So let's talk about environmental externalities. Remember, externalities are these little bit of extra good or bad that's happening because there's some sort of mismatch in between private marginal cost and social marginal cost, or private marginal benefit and social marginal benefit. This creates deadweight loss, which is loss in consumer and producer surplus from the economy because that there's some sort of misallocation that's happening. So we have a lot of tools that we can try to use to bring these together, but even with the tools, it's very hard and difficult to calculate exactly how much we need to correct for some sort of externality. Now, one or some of the most famous versions of externalities are actually mostly pollution related, and that's because these are things that can very easily affect others, right? If I'm noisy at my own house, my neighbors can move, or they can better fortify their house. That's not really a huge issue. It is an externality, but it's something that we can have some sort of process or solution for. But things such as acid rain or coal particulates that end up in a completely different state, or poisoned water systems, these are much larger externalities that can affect millions of people even unknowingly sometimes. So it's something that we have to think about when we're considering our public economic responses to policies. So let's, on the idea of particulates, let's talk about particulates because these are ones that are just well documented. We know that they kind of exist, right? We have acid rain, which is a huge problem in the United States, which is kind of caused between chemical reactions and different sort of compounds when sulfur dioxide and nitrogen oxides, they're released into the air from burning coal. They mix with hydrogen and water and oxygen and all, well, I guess water is actually just oxygen and hydrogen, but combined with these different elements up in different sort of storm systems or in the atmosphere, and then it ends up having, so these particulates cling onto the water and then rain down upon the world, right? This can cause pollution for waterways, this can cause pollution for marshes and ecosystems, and it can cause rust and sort of damage to your house or your vehicle or anything else over time. It's particularly bad in the Oklahoma area. Anyways, so these particulates tend to be a negative production externality, right? We burn coal because we want electricity and we want to be able to produce things, which are kind of nice. We like having things. We love having electricity. It makes things very convenient. I mean, I get to record this super awesome lecture for you that I know everybody is very excited about. But there's also some bad things that are happening too. These negative production externalities exist that take away from consumer and producer surplus because society would prefer that we burned less coal, right? Or we burn coal in a cleaner way because we actually have a lot of these externalities that are getting produced during this production process. 2/3 of the sulfur oxide emissions actually come from the Ohio River Valley, from just coal-fired power plants there. Random fact. So we have these different sort of acid rains, we have visible soot matter that does cause very unique problems that are pervasive and just across the board. Like it can affect the water systems and therefore the mental development of infants in certain areas, or it can cause heart attacks, or it can cause damage to different sorts of buildings. how do we actually calculate what the externality value of this is? How do we figure out how to tax that, or how to deal with it, or what even the optimal amount of pollution is? I mean, that's a very difficult thing for us to be able to rationalize, nonetheless calculate. So what are some of the damages that we typically see from particulate matter, right? Some of the negative effects are like environmental damage to water and ecosystems. We see property damage to painted surfaces such as automobiles, our stone exteriors, our metal. So that's why you have to like repaint your house way more often than what you would if we didn't have acid rain problems. Reduced visibility because there's suspended acidic chemicals, i.e. smog. There's adverse health outcomes where people who live upwind of a lot of different coal burning factories tend to have a lot of lung and heart diseases. So these are just lots of really interesting and pervasive negative production externalities that are happening. So what have we done so far? Well, Congress in 1970 actually got together and passed the Clean Air Act, which was a landmark federal legislation that first regulated damaging emissions because they set a maximum standard of atmospheric concentration of various substances. These are the ones that went around and they said, okay, all right. We need to clean our smokestacks. You got to get those like water jet things that you put in the smokestack, so the smoke that rises through the smokestack is like way less poisonous to the environment. That ended up causing its own issues because a lot of this water was now highly poisonous and they didn't really have anywhere to put the water. So they just kept digging holes to put the water in, and then they'd like circle them around with concrete and be like, that's cool, and just like leave it there. But then the problem is these holes would get holes in them in the concrete, and then they would pollute the local watershed, and then you have polluted water for decades. Anyways, so they have this Clean Air Act, which is supposed to regulate specifically the atmospheric concentration of different substances, but it only affected new plants. So they said, you know, it's way too difficult to go around to every single old coal burning plant in the United States and say that you have to spend your own money to clean your smokestacks. That's very difficult to do. So instead, every new plant that gets built has to have clean smokestacks. Well, then we ended up seeing a very interesting and different type of externality arise. It was that there's now an encouraged use of dirty old plants, right? If I was a new person who wanted to come in and I wanted to burn coal for a project, what was I going to do? Was I going to buy the dirty plant that's kind of been out of business but is still under this regulation where I don't have to pay for all these cleaning techniques and I save money on that, so I'm going to use this like dirty, polluting, bad for the environment factory? Or do I go for the new factory that's going to cost me now millions and millions and millions of dollars extra? That's a tough call. There's lots of people who would prefer the dirtier plants, and unfortunately that's what we saw after the 1970 Clean Air Act. That's why there's not many new coal burning plants that have been built since 1970, and why some of the ones from the 50s and 60s, though completely dangerous to operate, are still operating today. Right? So the Clean Air Act reduced a lot of the SO2 emissions, but it encouraged the use of these older plants that might have actually been inefficient. So we have to think, is the deadweight loss of using these older inefficient plants more or less than what we were getting from just like having people have pollution out of their own smokestacks if the factories would have gotten progressively cleaner or easier to maintain over time compared to these dirtier old ones? That's very interesting to think about. So in 1990, we added on an additional amendment because we said, oh, it's probably not good that we have a bunch of factories from the 1950s running and we're not building anything new, and these are just getting progressively dirtier. So now we're going to have this emissions trading. What emissions trading is it's a system of essentially voucher tickets. Right? This feature of the 1990 amendment to the Clean Air Act granted plants permits to emit SO2 in limited quantities. So what the US did is we said, we're going to accept so much pollution, right? And we had this X number of pollution that we would accept. And what we did is we took a couple tickets from it and gave it to plant A, and a couple tickets of it and gave it to plant B, and a couple tickets of it and gave it to plant C. And they all had a right to pollute up to those amounts. But what we allowed was for these permits to be tradable. We gave them to every single plant and allowed them to trade amongst themselves. So if I didn't trade, I would have a limit of, let's just give an arbitrary number. These aren't actually real. Let's say like 250 million tons of particulates. Ooh, actually that's a lot. Let's just say 250 tons of particulates. So I have a right to do that. Now, if I was a clean plant, I'd be looking at all those dirtier plants over there that they can't efficiently clean themselves without costing millions of dollars. Now I say, I'll sell you one of these tickets for about $900,000 each. You don't have to pay $1 million for the new smokestacks. Instead, you can just pay me $900,000. And a lot of them will take that, and I'll end up trading my tickets. So I will be producing less emissions, which is fine because I'm a cleaner factory. I could have done that for cheaper. And then the dirtier factory is allowed to produce a little bit more pollution in exchange for me producing less. That's what these tradable tickets did. It still gave us one limit of pollution that we've designated as okay, but we allowed companies to trade amongst themselves. Now, why is this important? Because it brought something new to the table. And that's the idea that people could almost regulate themselves in a way, where we could just put a limit, but allow people to have the freedom or the necessity to be able to trade amongst themselves to where their optimal permission was. I didn't have to know how clean or how efficiently the dirty factory versus the clean factory could operate. I didn't have to know anything about it. I could just say, here's the acceptable amount, and let them naturally, as though led by an invisible hand all the way back to Adam Smith, trade these tickets amongst themselves to be able to develop their own system of cost for tradable permits. That's neat. That's one of like the coolest parts of public economics, is that sometimes you have a policy provision that is so unique that it's just fascinating because it allows people to just do what they would have done and the world ends up a better place. Anyways, so how do we even set the total amount of pollution? Well, that's kind of a difficult one because then we don't even know really the adverse effects, right? We know that particulates equal bad, but how many particulates equal bad? How bad? What is the economic cost of this? Well, that's very difficult to figure out. So there's been a couple interesting studies into the adverse effects of particulates on health. One of the ones that I thought was particularly interesting was actually Che and Greenstone from 2003. Because this is one of the first quasi-experiments that looked at infant mortality rates. What they did was they took a bunch of areas that were affected by the Clean Air Act and a bunch of areas that were not affected by the Clean Air Act. We watched where they went before the policy went in. And then we put the policy in and saw how they differed in the number of infant mortality deaths. Now, so some areas were attainment areas, which means that they didn't have to reduce SO2 levels. Others were non-attainment areas, which were required to reduce SO2 levels. And then what we essentially saw was this graph right here. There's a threshold level of like essentially micrograms per cubic meter that we would have been okay with. We saw people in non-attainment areas, so these were ones that were requested to put in the Clean Air Act because they were dirty pollution, and they said, you know, you have to clean it up. And then we had other people in emissions in attainment zones that didn't have to change their behavior at all. What we saw in the areas that didn't have to change their behavior is that firms actually just over time get naturally a little bit cleaner and more productive when they have their emissions. That's just a factor of, as technology gets better, it's easier and cheaper to clean particulate matter. But what we saw in the non-attainment areas, these ones that had to change their behavior, is that they actually had high amounts of these different pollutions. And then boom, the Clean Air Act came in and it started getting phased in over time, and we just saw these drop, where the pollution in the surrounding area just dropped. And they still were able to trade amongst themselves. They were able to get to their own level of emissions based upon prices that they were setting themselves with these tradable permits. But overall, the world had less pollution from that, which is just kind of a very fascinating thing to look at. So this is one of the original papers. This is the, Clay and Greenstone one. I actually have a friend. This isn't very interesting, but I think it's kind of cool. I think it's really neat research. So I have a friend named Wes, and it's Wes Austin. I think now he's at the EPA is where he just started out. What he did was he took the same experiment because they were afraid that there might have been some sort of cross-contamination in airways from other areas because wind blows, right? So it could be that some areas that didn't have to reduce their pollution might have still had pollution that was being carried over from the more pollution areas. So what they instead did was they started testing the infant mortality outcomes based upon areas that had these groundwater pools. So essentially the ones I was talking about where they would put water through the smokestack to clean the smokestacks, and then they'd have all this poison particulate water that they didn't know what to do with, so they just kind of like put it in these coal ash dumps and all over the United States. They're everywhere. You see them on like the side of highways. So they just started like looking at infant mortality rates around these areas and found out that like, yeah, these particulates are actually a really bad thing, because even in places that had no sort of air pollution whatsoever, if they were even somewhat in access to these water pollution areas, they were still having similar like outcomes in childhood cancer and things. So anyways, that's just interesting. So has the Clean Air Act been successful? Well, that's a very interesting question to think about. And it depends, right? It depends on what measure you're actually thinking about it in. It led to dramatic improvements in infant health. Children were living longer. They were much less likely to die under the age of 5. But on the other hand, when running these same numbers, we realized that this cost 600,000 jobs and put 600,000 families out of work. And it cost $75 billion to different sort of polluting industries, which means that they had to raise their prices for customers. So children are safer. Lots of families unemployed and very expensive costs that are being passed on in high prices to families that are now unemployed and can't necessarily afford them. How do you balance those? They're not exactly similar things that you can just analyze because they're difficult to put numbers to. And this is a perfect example of where externalities, this deadweight loss that happens to society, and market failures, where we have these gaps in between the private marginal cost and the social marginal cost, have some sort of overlap together. Because externalities and market failures are really part of the same system. They're part of the same issue within society, is that we have one thing that either outcome can be relatively bad, and we have to figure out what the weighted potential of each of these are. So I don't know. I just think that's a really interesting framework to start us in this. So let's talk about climate change. You know, we're already on acid rain. Let's stay up in the clouds. Let's talk about climate change. All right. So global warming, serious environmental externality. We already talked about this a little bit in kind of a previous lesson. When we get to national level policies, it tends to be a lot of climate related things, right? So we have this greenhouse effect, which is just kind of the process by which gases in the Earth's atmosphere reflect the heat back to the sun. That's why it was really bad for us to have like a lot of CFCs, because then it gave us a gap in the ozone, because all of these lights were coming in and they were bouncing too much and they were creating holes, and it was just a bad thing, right? This causes global temperature to increase rapidly, and it's something that lots of different countries have had different policies to try to address, which means this is, unfortunately, a very interesting experiment for public economists to look at, because we can see how different policy prescriptions both affected people and affected the environment. It helps us write better policy later, because if we can figure out what works and what doesn't work and how to do it cost efficiently, then we can help create a better set of policy the next round and continue on and on until we find a way to find a solution to a problem that multiple people can be happy with, right? So what sort of international cooperations did we originally see with climate change? So climate change, we really kind of knew about it all the way back from like the 1920s to the 1950s, where we really started to have a lot of science and technology on this, but we first had a really big meeting related to climate change with the Montreal Protocol of 1987. This basically banned CFCs. So back in the day, ask your you know, cool, way too old aunt, I don't know, about Aquanet. I think that's what it's called, like this hairspray that had CFCs in it, and everybody was using it, and they were using all these other beauty products and things like that that had these very harmful chemicals in it, and they didn't think much about it. They thought about, oh, look at this cool 1980s hair. My hair is so big and awesome. But CFCs were one of the primary leading issues that caused a 25 million square kilometer hole to open up in the ozone atmosphere. So they got together for the Montreal Protocol and decided to ban CFCs, which is why you can't buy it in pretty much any country, and it's no longer really under production, because they saw that it was causing massive environmental degradation. It was like aerosol sprays. Anyways, so once these were banned, we actually saw some very interesting things happening. Over the next 20-30 years, we've now seen this hole in the ozone that's happening over the poles start to shrink. It's looking like it's going to be back to normal by 2070 if we keep on our current track. So that's just a way of showing that, like, hey, maybe this is a policy provision that did have some sort of meaningful or measurable outcome. But how many jobs were laid off because we ended up closing these factories, or we no longer were producing these chemicals? So that's something that we have to consider too when we're striking these balances. Another major one for international cooperation was actually the Kyoto Treatment of 1997. So when we first started realizing that global warming was getting bad, and if we didn't stop or lower some of these emissions, we were going to have a big global warming issue. I mean, it's something that we still debate all the time, right? So 37 industrialized nations got together in 1997 and they agreed, you know what, we're going to combat global warming. And we're going to do that by reducing carbon emissions. This was not ratified in the United States. I'm just talking about the international cooperation, but the United States did not ratify the stuff that I'm about to talk about. So this allowed for international emissions trading. Notice I had talked earlier about the Clean Air Act in 1970. That had been an awesome experiment. We figured out that yes, we can lower emissions outputs or particulate deposits just by allowing people to have these tradable permits. We set one level of pollution that we were okay with and then let them choose their own prices and trade in between them so that the permits would go to kind of the dirtier firms and the cleaner firms would be offset and benefit financially for it. So there's more of a reason for people to become clean firms as opposed to dirty firms over time. This allowed it on an international scale. There was now 37 industrialized nations. So I'm not talking about developing nations. At this point, we are talking about like OECD level developed nations. 37 of them got together and said, we're going to come up with emissions permits and we can kind of just trade them amongst each other. Well, that's fascinating because that's scaling up something that we had. Well, that's actually been tried by multiple countries, but in the examples that we're studying in class, this is scaling up something that in the United States we had seen as a 1970s experiment for one type of pollution, and now putting it on a much larger type of pollution with intercontinental cooperation. So that's pretty interesting. So can these environmental agreements actually make a cost-effective resolution? Because we have to think about a couple different things, right? We have to think about like, are we making the world a better place? Are we helping people? But also what the cost is, right? Because a lot of the time in public economics, what we have to do is we have to look at, okay, so we saved the river and we saved this ecosystem, but how many people did we put out of work? And what were sort of the costs that were associated with that? And how many different areas did we have to destroy to be able to try to offset this? And we have to look at these good and bads and try to make them sort of comparable. What one of the goals of public economics is to take a lot of these goals to help the world and try to figure out how to do it in a very cost-effective means, right? So this international emissions trading was fascinating when they came up with it in the Kyoto Treaty, because these industrialized signatures were allowed to trade emissions right amongst themselves. It was like the dirty and clean firms. Instead, it was dirty and clean countries that were finally just kind of trading amongst themselves. This allowed for kind of efficient countries to reduce their emissions on behalf of less efficient ones. So ones that had already had a lot of technological processes and a lot of technological growth were able to very cheaply reduce their emissions to offset some of the increased emissions from other countries for a financial payment, right? So let's look at two different graphs. So in this first one, we're going to be looking at the carbon reductions on our x-axis versus the price of the reduction per ton of carbon. Apparently it's a lot per ton of carbon, right? And in this, we have a no trading environment. So we see that we have the United States, we kind of have the rest of the world, and there's no trading in between them. The marginal cost of achieving the Kyoto target of a reduction of 440 million metric tons, as measured by the US curve, is $210 per metric ton of carbon if we were to do it in the United States. It's actually pretty high cost for us to reduce our carbon emissions at this point compared to a lot of other countries, which is why tradable permits kind of make sense, right? Other nations tend to have much lower marginal costs. So see that we have this increased line right here for the US's cost of reducing carbon emissions per ton, and there's other places that their marginal cost might be reduced so that they can do it for a slightly cheaper rate, right? For these nations, reducing about 190 million metric tons only cost about $20 per metric ton of carbon. So instead of having this large amount right here, where it would cost us a sizable amount to reduce, what would happen if instead there was some sort of tradable permit system where we could work together, where maybe the United States does reduce some, but other countries reduce more in exchange for a monetary payment. What would that even look like? So this is the non-trading world, but let's introduce trading to this. So any reduction that costs more than $50 per ton can be offset by purchasing permits, right? So right here, if at about $50, okay, well, all of these additional tons that we would like to offset, that's very expensive for us to do. What if instead, because it's cheaper than what it's really costing other countries, we give them $50 and then they pay the $20 to reduce for that amount, and then the reduction is still happening without necessarily having to do it ourselves. That's one of the cool parts about trading permits, is like solutions like that can organically happen without having to understand the nuances of every country or every player within a system, right? So any reductions that cost more than $50 per ton can be offset by purchasing permits instead. At that price, the US would choose to reduce its own emissions by 40 million metric tons. So yeah, we would end up reducing up to this level. And by distributing that reduction from our high-cost United States area to other low-cost nations, by instead having those payments so that they could reduce in exchange for our higher-cost emissions, we ended up significantly lowering the price of reductions worldwide by international cooperation in a way that's way cheaper. Look, $50 is way cheaper than the $210 that it would cost per metric ton of carbon reduction. And that's just by having a simple agreement where you can work out with some sort of trade and balance system, right? So notice I kept saying over and over, industrialized nations. Well, that's because we actually see something very interesting when it comes to developing nations. So a lot of developed nations already have the smokestacks. They already have the developed infrastructure. They already have the healthy train systems, for the most part, commercially. But it's projected that by 2030, developing nations will produce more than half of the world's emissions. But the thing is, their growth curves are different, right? When the United States and Britain and many other OECD countries industrialized, they ended up having rapid periods of growth while using very dirty technology. And then as our growth has kind of slowed down a bit, we're starting to clean our technology bases. But it took that dirty, sooty technology to be able to make some of these initial progresses. Well, for developing nations, they're at the beginning of that curve. So if they went originally just to this very expensive, cleaner ways of production, it may not give that same ability to grow at that same fast initial pace to become from a developing to a developed nation. So if they participated in the Kyoto Treaty, it would actually reduce the cost of the treaty by a magnitude of 4. But developing nations in general won't know part of this agreement, because why should they be forced to be environmentally conscious to miss out on this initial high periods of growth using dirtier technologies because of the mess that other nations have left behind by global warming that's caused by their own emission systems that they had previously. So it's a high thing of contention when we're actually looking at international carbon usage agreements. So in the United States, what has Congress tried to do about this? We haven't actually had any major pieces of legislation that have gone through for different types of global warming or addressing global warming in a long period of time. In 2009 is probably our closest idea of something at least passed through the House, and then it got shut down in the Senate. But in the House, in 2009, we had the American Clean Energy and Securities Act. It was supposed to help combat global warming by lowering the limit on the amount of emissions that firms could produce. And they were going to give firms lots of different options. So they could either reduce their emissions themselves, or they could purchase emissions permits from other people and trade it amongst themselves, or they could purchase pollution credits, where they kind of like pay the government or some sort of entity to just offset their emissions. So they kind of pay like a fine for it. They have lots of different options available to them. So the House thought that this was a pretty good idea, but then it ended up having a lot of criticism, right? Because a lot of people feared, like, this new cleaner energy is actually just a very high initial cost. It would end up putting factories out of work and millions of people potentially out of work. Some felt the full value should just be rebated to customers, because we're going to have this very expensive cost, which is going to make prices go up. So instead of giving it to these firms to be cleaner, why not just give it to the people? And that was something that a lot of people argued about. And I'm not arguing that any of these ideas are right or wrong. They're all very different and they matter differently to different people. But these are criticisms that we heard at the time. And that's why when this went over to the Senate, it ended up failing as a bill, because anything that's been clean energy or combating global warming related in the United States has been highly contentious ever since, you know, the early days of the 1970s Clean Air Act, which some people still aren't really happy with. So that's kind of the idea of our environmental regulations, and a very fast and dirty overview of here's what we're seeing on the international scale. Here's how public economics kind of affects, you know, multinational treaties, either within our own nation and states or moving within different sort of countries, and how we can use a system that allows people to make their own decisions in trades to maybe get to a point in which we had agreed is the outside factor or the end goal result. So that's a little bit about environmental regulation. Like I said, these are two smaller sections that didn't quite fit anywhere else very well, so I decided to put the two of them together. Now the next one's actually going to be public defense. So feel free to pause the video here, because these are two very different topics. You know, get up, drink some water, water's good for you, stretch your legs. But after that, we're going to talk a little bit about public defense, because it's something very interesting. We reference it all the time in public economics courses, right? Because it's this big idea of we have a non-excludable good and we have a non-rival good. Well, what's an example of that? And then everybody says public defense, right? Because it's, if you don't pay for it, you can't really stop getting the benefits of it. If we go to war, we can't say like, oh, these 10 people didn't pay their taxes. That's not possible or feasible. But it's also non-rivalous. If one person is protected by a standing military or some sort of public defense initiative, that doesn't stop another person's ability to be protected by that same initiative. So it tends to be a really interesting public good that people like to talk about, but it's something that's been under-researched for years. So defense is commonly referred to as a public good. You can't just exclude someone from being protected by a military interest because they didn't pay their taxes or into a particular system, and one person being defended does not affect someone else's ability to be defended. Now, let's have a bit of history related to public defense. The study of public defense in economics is a very, very new field within public econ, and we actually call it economic security. So there's a whole variety of economists that their entire job is they want to study these topics. Economic security is kind of the ability to protect or advance U.S. interests in the face of events, developments, or actions that may block these interests. Now, these can be acts of war, it can be acts of peace, it can be natural disasters, it can be international treaties. There's a wide variety of things that happen within the subfield, but it's based around the idea of promoting U.S. economic interests, right? So surprisingly, very young topic, starting to become popular with one of the RAND publications that came out back in, oh, which if you don't know RAND, it's a health group. They produce PhDs and a lot of very interesting research. But they put out a publication about 10, 15 years ago, and since then it started to become more to light of, hey, maybe this is something that we should start studying, because beginning with the post-Cold War era, it's kind of been gaining prevalence of how do we really think in economic terms of military or non-military presence or national defense on a very global and connected society, because this isn't just people on a boat, right? This is cybersecurity and long-standing wars and increasing tied economic performance in between different countries and currencies that has never existed before. So understanding these nuances is an important subfield, right? So there's kind of a broad view of economic security, is that it's based in research focused on challenges that are either foreign or domestic in origin. They can be intentional or accidental, and they can be the consequences of either human or natural force. That means if there's an earthquake that happens and a tsunami happens, how do we end up dealing with the economic ramifications with that? If there is an intentional threat upon the U.S., what is the economic implications of this? How about a pandemic? Or how about a long-standing war or research and development? All these interconnected parts are what we call kind of this economic security bubble of this new research field. A lot of their main goals are to maintain access to foreign markets, no matter, you know, what sort of prevalence is happening, whether it be an intentional or accidental, human, natural force, domestic or international incident. How do we maintain access to foreign markets, create stable international financial environments, promote market-oriented economic policies, maintain functioning international, commercial, and financial infrastructure, and equitable distributions of domestic income. It's essentially, how do we relate on this new global field in a way that hasn't necessarily been connected before? So it's just kind of the broad view of it. So the economic consequences of national security policies have two main components that they tend to talk about within this literature. The first is the way in which military instruments may be used to generate economic effects, right? For example, a lot of the research and development that's funded by the US military is used for a variety of different things. It's making different sort of ways to cook meals. It's making different sort of ways to develop medicine. It's also making different ways to have a lot of commercial and valuable spin-offs so that there is some sort of productive trade that can be an export, as we're already a highly import versus export country, right? So logistics, military services, emergency assistance to other countries. Like, for example, when there's a massive tsunami in a country, what is the viable economic impact of military infrastructures that can be used to be able to offset or help with a lot of emergency or crisis situations? So that's part of what this economic security field is. So that's part one of the economic consequences of national security policies. The part two, that's also the second half of what this subfield studies, is the ways in which economic instruments can be used to substitute or complement military instruments. For example, embargoes deterring forces through displayed competence. It's the idea of having a military presence in South Korea when there is different sort of animosity with North Korea. It's the idea of having strategic outposts across the entire world at that point. There's actually this really interesting book. It's called like Confessions of an Economic Hitman, and it's one of like the earlier ones in just economic security and the inner workings of how an economist kind of had to go to different countries and work together with all these underlying economic instruments and how it can complement a lot of military or security objectives. So I don't know, that's just kind of neat. It's an interesting book. So the economics of defense is often tax funded, right? Because it's a public good, and it's a public good that we don't necessarily want to privatize. So a lot of public goods, when we say, hey, how can we correct for these externalities of a public good, or how can we get people to pay for a public good, we start to say, okay, well, what we need to do is we need to privatize it in one of two ways. We can either get rid of the rivalrous part, where we're going to make it so that it does affect someone else, or we can get rid of the non-excludability part, which is the most common one. For example, if there's an open field and we have the tragedy of common issues where everybody's coming in and grazing their cows there, and all of a sudden there's not a field anymore because everybody overate it or overpopulated it. Well, if you privatize it and allow someone to charge a fee for people to come in and have some sort of rules or regulations based upon how many people can come into that field, then you make it so the field can be more sustaining, but it's no longer a public good. You've gotten rid of one of the two criteria, which is rivalrous or excludability, right? Defense is something that's argued that you don't necessarily want to do that with. It may not be the most efficient to instead privatize the defense force. So it's often tax funded because it's difficult to have finance through either altruistic or private behavior. You're not going to find anybody who says, you know what, I have a spare like $1 trillion that I would like to give to the US military. Like, no one has that sort of money sitting around, right? That altruistic or private behavior just isn't feasible because that amount of private money just is not existing in the United States. So since it can't be reasonably privatized to address excludability or rivalryness, that's why it ends up being tax funded. Now, this is one of the examples where it's very difficult to meet the expectations and wants in all the individuals represented, right? Because there's 340 million people in the United States, and they all have extremely different opinions on economic security because there's just so many different facets of it. So this creates a coordination problem where it's very difficult to be able to rationalize and and implement a program that's to the best interest of every single person. We also have this idea of asymmetric information that happens within these different sort of economies of public defense. Asymmetric information just means that both sides of a transaction don't necessarily have equal information about the transaction. If we pay our taxes, we don't necessarily know when that goes to the U.S. military, how it's going to be spent, what exactly it's going to be spent on, what sort of missions they're doing, what sort of different sort of security protocols there are, or different goals or things. There's an asymmetric information where not both parties within the tax payment system don't have all the information on what there is, which makes it so it's very, very difficult to be able to coordinate to the best parts of everybody's wants. So that's just, like I said, these were two kind of smaller sections that are interesting to public economics, and they're very useful to understanding national public economics. But the thing is, environmental regulation, when we're starting to talk on an international scale, is kind of a smaller section, and then the economies of just economic security is a very new field that's young, and we have years and years to try to figure out what exactly is going to happen with it. So if you'd like to talk more about either of these two sections, let me know. But that's going to be our information for this week. I'll see you all in class. Remember, if you are unable to make it to class in a week, I really need to know as soon as possible so that we can have alternative assignments for you. For example, if you were in quarantine or you were unable to come to class for some sort of other mitigating circumstances, please let me know ahead of time. I really need to know by the Wednesday of that week. Okay, everybody, I hope you have a wonderful evening. Enjoy the rest of your day. I'll see you soon. Bye-bye.